Hello and welcome. Today we're going to be looking at nonlinear equation graphs as part of the Passport to Advanced Mathematics, where we apply the skills we learned in the heart of algebra. As always, we're going to be going through 5 questions. We're going to explain them, and we're going to look at their intricacies so that you can ace the SAT math portion. As always, if you like these videos or found them informative, please be sure to like and subscribe. And with that, let's get started on our first question. And it is the functions y equals 3 times x plus 2 squared minus 4 and y equals negative 3 times x plus 2 squared minus 4 are graphed in the xy plane. Which of the following must be true of the graphs of the vertexes and the axes of symmetry of the two functions? All right, let's see what we can do here. Well, the first answer choice, the functions will have different vertices. Well, do we think that's true? Let's look at the functions that we have. The only thing that's different about them is that the first part, right? The actual squared part, the actual quadratic part is being flipped, which means that everything inside of that is the same, and there's going to be the same vertex. It's just going to be flipped, right? The same thing will happen with answer choice B. It's going to be the same axis of symmetry because it's going from this, can't draw it yet, but it's going from this to, so this is going from that in the first one to something that looks like that in the second one. That's really what's happening, right? It's just being flipped over that axis. That's going to have the same axis of symmetry. So we see the last two choices, and they're debating about which one has a minimum, which one has a maximum value. Well, let's see. The first equation goes up like this, so it's going to have a minimum value. If it's positive, it's always going to have a minimum value. The second one is going to be like this, negative, so this one's going to have a max value, which is right here. So the first one's going to have min, the second one's going to have max, and which one does that say? The function first one will have a minimum value, the second one will have a maximum value. That is answer choice C. So that's our answer. And let's move on. All right, question 2. And here it is. 2 parabolas are graphed in the xy plane and have equations 2 times x minus 4 squared plus 2 and negative x minus a squared plus 12, where a is a constant. For what value of a will the 2 parabolas have the same axis of symmetry? Well, it might be helpful first if we found the axis of symmetry, right? So this first parabola is going to look something like, if we draw the xy plane, then the first parabola is going to look something like this. That was a horrible parabola, but it's going to look something like that, where this point right here is 4 and 2. Because if we plug it 4 as x, we just get 2 at that point. Now the axis of symmetry here is going to be right here on okay, I cannot draw a straight line apparently, but that's fine because we have a line tool. This axis of symmetry is going to be right here at x equals 4, which is right what was in here, which means that x minus a squared is going to have x minus 4 squared. So a has to be equal to 4 so that it can have the same axis of symmetry, even if it's something different, like it might be it's going to be something like this, right? Something like that, or actually, since the constant is bigger, it's going to be something like this. But it'll still have the same axis of symmetry if it still has the same x equals 4, or the a equals 4. So a is going to be equivalent to 4. Looking at our answer choices, that is, a is 4. So that is our answer, and let's move on. All right, question number 3. Here it is. Functions f of x equals 8 times root of 5th x and g of x equals 8 times b dx are graphed in the xy plane. For what value of b will the functions f and g be symmetric with respect to the y-axis? Let's just draw out our xy plane first. So this is our xy plane. And let's graph the first one. So we're going to, at 0, at x equals 0, we're going to be at 8. And from there, we're just going to go down more. And then the other way, we're going to go up. And the other way, right, if we flip that, it's going to be something like this. Or try that again. Something like this would be there, and this goes up like that. Which means that the fact that's being multiplied is opposite. The opposite of 2/5 is 5/2. So B is going to be equal to 5/2. And this opposite flipped graph, 5/2. And that's our answer. Let's go to the next question. Here it is. The functions f of x equals 5 times 2 to the x and g of x equals 5 times b dx are graphed in the xy plane if the graph of function g is always increasing and f of g is greater than f of x greater than g of x for all x greater than 0, which of the following could be the graph of b? Well, let's see. Graph of the function g is always increasing. This is always increasing. So what does that mean? Well, it means that it has to be greater than 1. Because if it was less than 1, it would go like this when this is y-axis, right? If it's greater than 1, it's going to go like this. So we can scribble out, cross out first one right here. We can also cross out answer choice C, because we know that f of x has to be greater than g of x. And if we do this, it's going to be the exact same thing. So that doesn't work. So now we're stuck with something that's less than 2 and something that's more than 2. Let's think about this. So if we have this is the initial function, right? This is the initial function. If we have a factor that's less than 2, it's going to grow slower, right? So it's going to be staying here, but it's going to grow slower. So it feels like this should be the correct answer. Whereas if we had something that grew faster, it would be like, it would be way higher, right? And we can test this out. If we can plug in 5 equals x, and we can plug in 5 equals x in, or 5 equals b in here, and then pick an x value, right? Pick 1 as an x. And then this one is 10 right here. This is 10. And this one is going to be 25. And g of x is not less than f of x at that value. So 5 doesn't work, which means that our answer is then going to be 1.25 because it grows slower. So it's going to be less than for all x greater than 0. And let's move on. All right, question number 5, and here we are. Functions f of x equals -2 times 1 to the third x, and g of x equals 2 times 1 to the third x are graphed in the xy plane. If AB is a point on the graph of f, which of the following is a point on the graph of g? Well, let's see. So if we plug in a, right, into f of x, and we get that f of a, so we basically just get -2 times 1/3 to the a, right? And that's supposed to be equal to b, which means that -b equals 2 to the 1/3, 2 times 1 to the third a, which is just g of a. So a point on the graph of g is then just going to be a minus b. Looking at our answer choices, that is choice C, and we're done. All right, so in this topic, it's mainly just about taking these exponentials, these quadratics, any kind of nonlinear equations, and being able to see the differences between them, be able to visualize them in your mind's eye, or maybe you have to draw a rudimentary sketch of them, to be able to think about what their behavior will be at certain points, and that's really all this is about. I'll see you next time when we continue our study of the Passport to Advanced Mathematics. I'll see you later.